Good morning everyone. Today I am going to take a lecture on Discrete Mathematics chapter number 4 Algebraic Structure, and today's topic is the ring. Okay, so according to our previous lecture we have already seen in the group and the abelian group and the addition modulo, multiplication modulo, quotient group, normal subgroup, left coset, right coset, and the definition of the different types of the endomorphism and the homomorphism, isomorphism, automorphism. Okay, and the without zero divisor and with zero divisor. Okay, so for finding the group and the abelian group, we have already seen only one set, or you can say that one group. That means one set and the one operator. Okay, but only the mapping we use the two sets and the two operator. Okay, that means two group G and G dash and the operator and the star. So our today's topic is ring. So according to ring, we use the two operations. Okay, two operations, that means plus and addition, and dot, that means multiplication. That means for finding the ring, so we write here R plus dot. Okay, so ring, for finding the ring we use the two operations. Okay, so here what is the definition of the ring? So let capital R be a non-empty set with two binary operations. Okay, one is called the addition and is denoted by plus sign, and the other is called the multiplication and is denoted by the dot. Okay, so here then R is called a ring if the following three conditions are hold, or you can say that the satisfied. That means what? R plus dot, that means plus, that means addition, and dot, that means multiplication. So R plus dot is a ring if they satisfy the three conditions. So what is the three conditions? First condition is R plus, that means the set. Any set we are given in our question. Set, and the operator is what? Operator is plus, addition. Okay. So R plus is an abelian group. Ring is no doubt, ring is depend on the two operations, plus and the dot. But three conditions is what? First condition is with the help of we use any set. So with the operator plus addition operator, this is an abelian group. So abelian group, that means what? We satisfy the five properties. First one is the closure property, second one is the associativity, third one is the existence of the identity, fourth is the inverse, and fifth one is what? Fifth one is the commutative property. Okay, so first condition is what? R plus is an abelian group. Got it? Second one is R dot. Dot, that means multiplication. Okay. So R dot is a semi group. So what do you mean by the semi group? Semi group, that means the closure and the associativity property. That means the set with any operator if satisfied the two properties, closure property and the associativity property, then we can say that this is a semi group. Okay, that means R plus with respect to addition is an abelian group. That means we find out the five properties, and R dot is a semi group. That means we find the two properties. And third condition is what? Third condition is distributive law. Okay, so what do you mean by the definition of the ring? So ring is defined the R plus dot. That means according to ring we use the two operations, plus and the multiplication, addition and the multiplication, and if satisfied the three properties. First one is R with respect to addition is an abelian group, R with respect to multiplication is a semi group, and third one is the distributive line. Okay, so let's start one by one. We find out the different properties. So here in the left hand side we write here the addition, and here we write the multiplication. Okay, so first property is the closure property. So here first property is closure property. So we write here for A comma B belongs to R. Okay, A comma B belongs to R, then A plus B also belongs to R. This is the closure property. Okay, so multiplication is that means what? For A comma B belongs to R. Okay, then with the help of multiplication, A dot B also belongs to R. Why we write here this? Because of R plus is an availing group, so we find out the 5 properties. But R dot is a semi group, so we find out the 2 properties, closure and the associative property. So according to closure property, we consider 2 elements A comma B belongs to R. So here we use the addition. Okay, here we use the plus sign and here we use the multiplication dot. So A and B belongs to R. So A plus B also belongs to R. And here A comma B belongs to R. Then A dot B also belongs to R. Okay, so this is the closure property. Second one is the associative property. Associative property. So here we write the addition and here we write the multiplication. Okay, so this is the plus and this is the multiplication. Okay, so for A comma B comma C belongs to R. Okay, then A plus B plus C is equal to A plus B plus C. Okay, this is the associativity according to plus. Okay, and for each, or you can say that for all A comma B comma C belongs to R. Okay, then A dot B dot C is equal to A dot B dot C. Okay, so this is the associative property. Okay, next one is the existence of identity. Existence of identity. Okay, so existence of identity, that means what? If we consider an element and use the operator, given operator, so identity element, if we use the identity element, so we get the element itself. Okay, so here for all, or you write here for each, A belongs to R. Okay, there exists. So this is the multiplication. So what is the identity element? Identity element is what? According to addition, identity element is 0. And according to multiplication, identity element is what? 1. Okay, so there exists 0 belongs to R such that A plus 0 is equal to 0 plus A is equal to A. This is a identity property. Okay, and here does not hold. Why we write here? Here does not hold because of here this multiplication we find out R plus is an abelian group. Got it? But according to multiplication we find out only the semi group. That is addition we find the 5 properties and according to multiplication we find the 2 properties, closure and the associative property. So this is a semi group. Okay. Fourth is what? Fourth is existence of inverse. Okay, so existence of inverse, that means what? For all A belongs to R. Okay, so existence of inverse, that means what? If we consider an element and for example this is a plus operator, we are given in our question plus operator. So the A is an element, so if we use the inverse of that element, so we get the identity element. Okay, that means A belongs to R. So according to additive, okay, according to addition, what is the inverse of A? The inverse of A is minus A belongs to R. Got it? Because of we use the A plus use the inverse of this A, so we get the identity element, and the identity element is what? Identity element is 0. So A belongs to R, then there exists minus A belongs to R such that A plus minus A is equal to minus A plus A is equal to 0. Okay, so this is the existence of inverse. Okay, and here does not hold because of here we find only the two property. Okay, next one is fifth is commutative property. Commutative property. Okay, so commutative property, that means what? This is the fifth property. So for all A comma B belongs to R. Okay, then so commutative property is what? A plus B is equal to B plus A, and here does not hold. Okay, does not hold or does not satisfy. Okay, so here according to plus operator we write here the five properties, and according to multiplication we write here the two properties, only closure property and the associative property. Okay, so two conditions are satisfied. So two condition is what? The ring given R and the two operation plus and the dot. So according to plus, R plus is an abelian group. Okay, and according to dot multiplication, R dot is a semi group. So third property is what? Third property is distributive law. Okay, so what is the distributive law? So third condition is distributive law. Distributive law. Okay, so according to distributive law, for example, A comma B comma C belongs to R. So the first condition D1 A dot B plus C is equal to A dot B plus A dot C. Okay, and the second one is second distributive law is B plus C dot A is equal to B dot A plus C dot A. Okay, that means according to distributive law, here we use the multiplication and the addition, both the operators. So A dot B plus C is equal to A dot B plus A dot C, and the second one is what? B plus C dot A is equal to B dot A plus C dot A. So this is the distributive law. That means if we find out the given set or and the plus and multiplication operator satisfy the ring or not, so you consider here, always you take here the three conditions. First one is R plus, that means the given set and addition is an abelian group. Second one is R dot is a semi group, and third one is the distributive law. If all these three conditions are satisfied, then we can say that R plus dot is a ring. Okay, so here we write the R because of we see here the ring. Okay, so according to our question, we are given in any set for finding the ring. Okay, so I will continue this topic in our next lecture. Thank you for watching this video.